Good morning, everyone. So this is Rashmi from the Department of IT here with the explanation of our topic from the subject mobile computing. So far we have seen about the introduction and why this subject have been introduced into the curriculum, and then the basics we have covered in our unit 1. Then we have seen how the wireless LANs and the Bluetooth technologies are implemented in maintaining the mobile communications, and what are the hardware networks we are going to use in that with the applications. And now we have into the main link or the interface that is used for the main communication in the mobile communications, that is our mobile transport layer and the database issues. Now let us see what are the contents that are present in our unit 4, then we'll be going one after the other with the other topics. So as we have seen displayed here, so we'll be covering about the mobile transport layer and the basic conventional model which we already know, which we have already learned in our computer networks also, along with the ISO 7 layers and the TCP IP for 5 layers. Next we have indirect TCP. Indirect TCP, snooping TCP, mobile TCP and other transport networks. These are the TCPs which are being suggested apart from the traditional TCP IP. And now why they are suggested and what are the pitfalls what we have faced earlier also will be discussed in this lecture. Next we have database issues, database hoarding and caching techniques. Obviously, when we are maintaining a communication, it is the prior duty to check security as well as the database. So we'll just have a glance over database issues and the hoarding and how the caching techniques are going on to hold the entire data and keep it secure. Next, the client server computing and adaptation, transactional models which are helping the data communicate between the client and the server. And next, transaction models, query processing, data recovery processing and QoS issues. QoS issues is nothing but quality of services issues. How these models are working on making the queries come from server and client. How are they decoded? How are they processed from client to server? Who are there in between the client and server? We are going to see in this lecture. Now, first and foremost, we'll start with our first topic, that is our mobile transport layer, conventional TCP and IP protocols. So which is already mentioned here, we can see TCP is the transport layer protocol that serves as the interface between client and server. As we have seen already, it is used to maintain or to make the communication or dividing the data into packets and sending from one layer to the other. And what two layers are used here to transfer the data? That is our TCP protocols is used to transfer the data packets. Transfer the data packets between transport layer and the network layer. So what are the main things that are required to focus when we are saying we are using conventional TCP IP for the communication between two different layers? So what are the things that we need to concentrate and make a keen focus on? Now they are divided into 3. The main research activities in TCP are listed below, that is congestion control, slow start, fast retransmission. So in short, now here we'll remember that congestion control, slow start and fast retransmissions are the 3 main activities which need to be concentrated or focused for a perfect TCP IP. Now we'll see what is this congestion control, slow start and fast retransmission. How does it work or affect when we are going to implement? Right, congestion control. Congestion is caused often even when the network is designed perfectly. How did that possible? Now we are designed a network which is useful for sending data from sender to a receiver. Then even though when we have designed the network perfectly, what is making the congestion control cause? What problem is actually making this to cause? And we are saying on the other hand that the network is designed perfectly. That means it is not the issue of the network, but when sender is sending the data, sender needs also to know how much data packet I need to send to the receiver. What is the capacity of the receiver to receive the data? So based on that, I need to divide the packets and I need to send. That means the sender need to send the data packets depending on the capacity of the receiver, right? For example, when we hire a vehicle or a four-wheeler vehicle, For example, we have booked using Uber or Ola. We have booked, we have given the source, we have given the destination, we have seen all the fare costs from the destination to the source and how many minutes are they to reach the destination. But after we get that vehicle to us, we also get an OTP, obviously. After the cab arrives to our pickup point, when that cab person notices that there are more number of persons to travel, what will be the next step? Obviously, he will be rejecting the ride. Car is okay, it is maintained well, it is in a good service which he can pick and drop. But what is happening? They strictly follow hiring 4, only 4 only. Or you will say 5 or 6, that's it. Usually for to the max 4 or 5 with kids, they'll be allowing. Now why, can we blame that car is not proper or its service is not good and that's why this is done? No. We have the protocol, along with that protocol we'll be going. Now come back to our network. When a sender sends the data to receiver, even though we are saying the network is designed properly, what is making the congestion to happen? It is the data packets that is overloaded on the network while receiving to the receiver. That means sender is sending a data or the data packets in such a way that it is making the network bandwidth or the network frequency to get overloaded. And now when the burden in the network gets overloaded, what will be the consequences? The packets start dropping. When you can hold only 10 books, when you are overloaded with 100 books, obviously we'll just drop the books. Same way happens in our network also. When network is designed, even though it is designed perfectly, it is the sender and receiver's knowledge. You need to keep that the limit of the data needs to be sent in such a way. So now what happens when a sender decides to send the data? It is the minimum duty to know what is the window size of the receiver and with what capacity the receiver is able to receive the packets in the network, right? Now, if we know what is the capacity, now there is no question of dropping the packets, there is no question of packet loss. Now, when the packets get dropped on the network, the sender doesn't know, receiver doesn't know, only the packets which are received by the receiver thinks that these are only the packets which I am getting from the sender. Now, what happens? How do these both know that set of packets are dropped? Yes, again, absolutely, we already know from the basic knowledge that when a sender sends a data and a receiver receives, we will get a reply back packet which is named as ACK, that is acknowledgement. So, absolutely right. When the sender is sending a packet, upon the receiving of the packets at the receiver's end, receiver will send what? Acknowledgement. Here again the acknowledgements are of two types. One is ACK and another one is NACK. Now what is the difference between ACK and NACK? ACK tells acknowledgement, that is positive acknowledgement, upon the receiver's end after receiving the packets from the sender, they will send the acknowledgement. Okay, packet 1 sent, packet 1 received at the receiver's end, packet 1 acknowledgement is sent. Again packet 2 will be sent, packet 2 is received, packet 2 acknowledgement is sent. Likewise, all the packets will be sent and all the packets acknowledgement will be done. Now, what does this negative acknowledgement is speaking about? NACK. Same. Now, when the congestion control gets occurred, when we are sending more packets, packets will get dropped. We know that. Just now, I have also given a basic example. What about the dropped packets? Now, how will the sender knows? How will the receiver tell sender that I didn't receive so and so packets after 10th packet, I didn't get 11, 12, 13, 14, directly I got the packet number 16. That means receiver understood that there is something fishy in between this. And what's that? Because of the overloading of packets on the network, the packets got dropped. So receiver's duty is what? To tell sender that I didn't receive so and so packets. So kindly resend them. Now, how will sender know which packets to send? Sender is sending 100 packets, 100 data packets. How will sender know which particular packet I should send? Now, here comes the role of NACK, that is negative acknowledgement. So receiver will send, I didn't receive the packet 12, NACK 12, NACK 13, so and so, with the help of the name of the packets. NACK is for negative acknowledgement. That means this packet is lost. It is not received by the receiver. And so now what happens? After receiving this negative acknowledgement, sender will try to retransmit again the lost packets. Right? Now, pause for a moment and think why all this has occurred. Negative acknowledgement, okay, dropping of packets, okay. Why did packets get dropped? Because of overload on the network that is designed, right? That means congestion control always speaks about the congestion of packets. In other words, we can say overload of data packets on the network link. Right? So whenever the packets, data packets or the data gets overloaded on our network, though our network is designed perfectly, it will not able to handle the extra capacity of the packets. And then acknowledgement, negative acknowledgement comes into the picture. Right? See here, it's already clearly mentioned. If the capacity of the sender is more than the capacity of the output link, then the packet buffer, a router is filled and the router cannot forward the packets fast enough. The only thing router can do in this situation is to drop the packets. As we have dropped the books, same way the packets will be getting dropped. So what we should do and all, we will know, because in the contents I already told you, there are few mobile TCP, indirect TCP and other TCP models are suggested. Why they are suggested? Because of few drawbacks and limitations in the systems. So we'll come to that point once we see our see about the congestion control, fast transmission and the slow start. Right, slow start. The behavior TCP shows after the detection of congestion is called as the slow start. Means congestion occurred. That means already the data are getting burdened on the network. Packets get dropped down. Though you are dropping the packets, you need to hold the data which is there on the network, which are on the with correct capacity of the packets, right? Now because of this overload, obviously the transferring of the data from the sender to receiver will be slowed down, right? And so we are calling it as a slow start. Slowly the packets, because in between the packets will be dropped, network gets disturbances. Same when we when we are carrying our books or a bag with limited weight, we can carry. If we are putting much more weight books or any items, what will happen? You cannot able to carry it on your shoulders. Though if you are fixed that I need to reach my destination at any cost, somehow, whatever happens, I need to reach my destination, then you will carry that bag and you will reach the destination. But what will be lagging here? Time will be lagging. Your movement or your transferring of the data will be very slow. And see here what we have. How does the sender decide what is the capacity of the receiver window or network? How many packets I shall send? Because we told before sending, it is always a good practice that a sender needs to have a knowledge on receiver's window size, right? So, like a trial and error method, here they have suggested one small example showing that trial and error based time. Send one packet, check for the acknowledgement, double the packet, check for double acknowledgement, again double the packets, check for the double up. Until how many times you need to repeat this? Until you receive all positive acknowledgements, you need to continue. But once you get a negative acknowledgement, that means you have reached to the threshold point. At this point, you will understand that, okay, beyond this limit, it is unable to capture or it is unable to carry the data. So what we'll be doing in general, we'll stop sending the data of the size, window size beyond that threshold. So to understand that, we are sending and we are just checking, doubling and we are sending the double packets and we are just trying to know. As it is clearly shown, sender has sent packet 0, Acknowledgement 0. Acknowledgement means what did I say? Positive acknowledgement. That means our packet is received. Next, acknowledgement 0 is received. I am doubling the packets. Earlier I sent only one packet. Now I am doubling it to 2. So now I am sending 2 packets and I am just waiting for the acknowledgement. What acknowledgement will I get? Again, possibility is 2. Either I may get negative acknowledgement or a positive acknowledgement. So here in this example, 2 packets are sent, 2 acknowledgements I have got. That means successful reception is done at the receiver. Right? Next, 3, 4, 5, 6. Here 1 packet, 2 packet, 4 packets. Means I am doubling. As I told you, we will double. Next, 3, 4, 5, 6. Acknowledgement is 2. This will be continuing to 1, 2, 4, 8, 16, 32. Like that we will send the packets. We will check for the positive acknowledgement as a response. Right? Now, agar, first suppose you have encountered a negative acknowledgement. Means that is not the limit. What is the positive acknowledgement we got before that? That will be considered as the capacitor of the window size. Right? See here, number of transmissions and the congestion window in segments. You will be keeping on sending the packets and waiting for the acknowledgements and all. Again, the graph has fallen down, then it increased, then at some threshold, it will not handle the packets. And that when you can call as a control or a congestion control or a threshold point. Right. Faster is transmission. So we have, as we have seen in the earlier slides, 3 areas to be concentrated are congestion control, slow start and fast retransmission. In this fast retransmission, what it is mentioning? In TCP, 2 things lead to a reduction of the congestion threshold. One of those is sender receiving continuous acknowledgements from the single packet by conveying either of the 2 things. What is that? One is receiver received all the packets up to the acknowledged one. And the other is the gap is due to packet loss. Yes. Now when I send packet 1, 2, 3, whenever my packet are sent, receiver is receiving, there you will not have any time delay because I am sending, packets are going on smoothly in the network, receiver is receiving, right? But when does the real problem arise? When the congestion is increasing, at that time the real problem arises. So when packets are getting overloaded, our gap will be increased, right? And so this is called fast retransmission. Next, and it is suggested TCP models, ITCP, STCP, snooping TCP, and few TCP methodologies are given, right? So we will be looking after all this with an example and the network diagram in our next lecture. Thank you so much. कंट्रोल कर दिया हाँ पर बहुत चिल्लाना पड़ रहा है बहुत जोर से और इसमें 20 ऑन भी आ रहा है